When the leading coefficient of a quadratic is not 1, in this case it's 2, there are many ways the math teachers show to do this. A lot of times the way to do it is to guess. Be like, well, it's going to be 2x something and x something, and then what could go here? Well, to make 21, I have to do plus 7 and plus 3, or maybe I have to do plus 3 and plus 7, or maybe I have to do plus 21 and plus 1, or a minus 1. I'm not a big fan of guessing. Some teachers do a technique called slide and divide. I'm a big fan of that because it's like a little magic trick. It's very sneaky. But my favorite, the most kind of genuine way to do it is to multiply your A and your C values. In this case, 2 times 21 makes 42. And look for factors of 42 that add up to 17. So factors of 42 are 1, 42, 2, 21, 3, 14. I'm going to keep going. 3 and 14 are what I'm looking for, but I could also do 4, 5, 6, and 7. Or I could do negatives of any of these. Negative 1, negative 42, negative 2, negative 21, dot, dot, dot. In this case, the ones that make 17 are 3 and 14. I'm going to use those to rewrite my quadratic. Instead of a trinomial, I'm going to write it with 4 terms because I'm going to split up the 17 into a 3x and a 14x. I'm going to rewrite this as 2x squared plus 3x plus 14x plus 21. Right, I kept my quadratic term the same, and I kept my constant term the same, but my linear term, my 17x, I split up into 3x and 14x, which I got from here, of course. The reason I did that, look, I don't know how I wrote all over this, is now I can factor by grouping. I could split the problem in two. Out of the left side, I take out the GCF. Out of the left side, the greatest common factor is x. I can't factor anything more than an x out of that. If I factor an x out, I get 2x plus 3. And out of the right side, I could take out a positive 7. I pay attention to the sign here. If this is a positive sign, I take out a positive. If it's a negative sign, I take out a negative. Positive 7 factored out makes 2x plus 3. And now I have, on the left and the right of this red squiggly, I have a factor of 2x plus 3. So I could take it out of the whole thing. And what am I left with is x plus 7. That is the correct factoring of our original problem. So the zeros of this original quadratic are negative 3 over 2 and negative 7. Negative 3 over 2 makes this factor 0. Negative 7 makes this factor 0. I like this technique because if I'm guessing, sometimes I won't get it at first, and then I'll start to get worried, and then I'll work a little faster, and the more worried I am, the less likely I am to get it, and the less I'm getting it, the more worried I get, and it kind of spirals out of control. The other reason I like it is because this is how my Algebra 2 teacher taught it. If I do 5 times negative 18, which would be the first step in this process, I get negative 90, and I'm looking for factors of negative 90 that add up to negative 1. In this case, it's negative 10 and 9 will do that. I mean, there's lots of things I could do. 18 and negative 5, or I could do negative 2 and 45, but these two are factors of negative 90 that add up to negative 1. Negative 1 because that's what's right here, negative 1. So I rewrite my equation. 5x squared I keep the same. Negative 18 I keep the same. But the linear term I split up. Instead of negative 1x, I write negative 10x and plus 9x. The order I write them doesn't matter. I could have done plus 9x minus 10x. But what does matter, at least the way I kind of make it easy for myself, is when I draw my squiggly line, I keep the sign on that second term with the second term. In this case, out of the left side, I could factor out a 5x, and I'm left with x minus 2. Out of the right side, I could factor out a positive 9, and I'm left with x minus 2. Then I factor an x minus 2 out of the whole thing, and I'm left with 5x plus 9. Magic. In this problem, I'm going to multiply 3 and 2 to get 6, and I'm going to look for factors of 6 that add up to negative 5. That's going to be negative 2 and negative 3. Right, my other factors, those are all the factors of 6. Those are all the pairs of integers that can multiply to 6. The only ones that add up to negative 5 are these. I'll use them to rewrite the problem. 3x squared minus 2x minus 3x plus 2. Out of the left side, I could factor out an x, and I'm left with 3x minus 2. Out of the right side, I really don't have a GCF, but the fact that it starts with a negative means I'll take out a -1. If I didn't have a GCF at all and it started with a positive, I would take out a +1. But taking out a -1 leaves me with 3x minus 2. I know I'm doing this right since this and this match. If they don't match, I did something wrong. And when I factor a 3x minus 2 out of everything, I'm left with x minus 1. So that is the correct factoring of f of x. The zeros of f of x would be x equals 2/3 and x equals 1. For this problem, I multiply 9 and -10 and get -90. Oh, I already did one -90. And I'm looking for factors of -90 that add up to -5. So 1, -90, that's not it. 2, -45, that's not it. 3, -30, that's not it. Now I'll multiple 4, 5, and -18. Nope, not there yet. 6 and -15. Is that right? -15, yeah. That's not it. 7 doesn't go into it. 8 doesn't go into it. 9 and -10. 10 and -9. At this point, I know I've done something wrong because the way I'm writing these out, I know as I'm going, I'm checking if they add up. This adds up to -89. This adds up to -43. This adds up to -27. Because I'm kind of writing these in order, the sums are increasing every time. And I know that I'm not going to end up with something that adds up to -5 because it should have been here. So I wrote the problem wrong. So that's sad. I guess we'll change it. Maybe we'll do minus 13x. So I'm looking for something that adds up to -13. Oh my goodness, I found it! It's 5 and -18! Oh my goodness! So I will rewrite this problem as 9x squared plus 5x minus 18x minus 10. Out of the left side, I'll take out an x. Out of the right side, I'll take out a -2. And that leaves me with x minus 2, 9x plus 5. 7 times -20 is -140. Factors of -140. This is the first one that I genuinely look at and I don't go, oh, I spot it right away. 1 and -140. Nope. 2 and -70. Nope. 3 doesn't go into it. 4 and -35. Oh, that's it. 4 and -35. 7x squared plus 4x minus 35x minus 20. Out of the left side, I take out an x. Out of the right side, I take out -5. And I'm left with x minus 5, 7x plus 4. Let's see what we would have ended up with if we had put the 4 and the -35 in the other way. In other words, if I wrote 7x squared minus 35x, plus 4x minus 20. If I would have just wrote the -35 and 4 in the other order, out of the left side I would have taken out a 7x. Out of the right side I would have taken out a positive 4. And I would have been left with still the same thing. Which is encouraging. 4 times 30 is 120. Factors of 120 are things like 1 and 120, or 2 and 60, or 3 and 40. Oh, we found it. 3 and 40. 4x squared plus 3x plus 40x plus 30. Factors, factor by grouping. I could take an x out of the left side. I could take a 10 out of the right side. And I'm left with 4x plus 3, x plus 10. Factoring quadratics with leading coefficient. Now we are masters.